I'm Raghuram, Vice President of Engineering for Ecode Networks. Ecode Networks is a startup company which does SDN Solutions. So it's based in UK and it has an office in Mountain View, California. So we are here in the ONS presenting a showcase solution which we deployed for an end customer called Teneno. So the end use case is like this. They have deployed a NAS solution. So for this NAS solution, we have come up with a suite of applications which would orchestrate all the services required for the end customer on top of the network. So we in the SDN architecture sit in the application layer and we provide all the services on top of the network. So we work with federation of controllers like HP WAN, Open Daylight, Floodlight and different controllers, and all the controllers at once also we call it as control of controllers. So apart from the 5 applications which we see: monitoring, design, policy, analytics and traffic engineering, we have break down the applications into multiple, like a topology graph, device locator, simulation, policy. So we have break down the applications into multiple different applications. So going back to the use case, the customer Teneno has a use case of providing service. So they are a service provider which they provide NAT service, so networking as a service. The idea is like this: we have 2 companies, one in UK and another one in US. Now I want interconnectivity between these 2 hosts. The 2 users should connect to each other. Now if I have to do it in traditional networking, I'll get the boxes up, the switches, routers, I'll get all the gear and connect my offices. But what if I'm an SME? I don't want to spend my fortune on these devices. So instead I want a service which is agile, flexible and easy to connect. So how I do it is with this NAS. So Teneno have built up a NAS cloud. It would create a software and give it to the end customer, which they would install in their PC, and that would actually connect them to the NAS cloud. So once they are connected to the NAS cloud, that is where we come into picture and we orchestrate all the user intents into the application. So whatever the user gives us as an intent from the UI, we in turn convert into a policy and deploy it onto the network. So one of the policy or one of the intent is like this: the user wants to monitor what's happening with his network. So that is where monitoring application comes into picture. And the user wants to design his own network, like he wants to design which user connects to which app server, which user will connect to which database server, so stuff like that. So all this he does it from the UI and we implement it on the network. So a policy, the user might want to deploy in firewall engine just before the app server. So he want to block traffic flowing through a certain port, so that can be deployed through the UI. And there is a DDoS engine and we have traffic engineering stream coming up. So let's say the DDoS is like this: you want DDoS to be deployed before the database server. So we take the intent from the user, deploy it, and even the traffic engineering is similar. So the user wants the traffic between their app server and the users to be engineered. Like that means they want optimized path always. So from point A to point B, we find the best paths, and in the back end we continuously change the paths as per the best cost available. So the advantage with this is that the go to the network is very simple. He did not pile up the network equipment. He can pay as you go. And what we are doing is actually creating an agile network, which is speed onto deployment. You can design your network, you do change management, and then all at one location. So now the Teneno network has a layer 2 cloud fabric, where we take the user intent and does all the layer 3 to 7 provisioning onto the cloud fabric. We also integrate with the OSS and the BSS systems to provide the pay-as-you-go services. So going back to the intent, one of the intent, as we discussed, is to monitor what is happening with the network. So let's say the customer Teneno wants to see how his network is behaving, right? So we have a dashboard for the Teneno, where users can see what is the number of switch counts or virtual points of presence, and they can see how many end devices are connected to the network. They can see what is the percentage utilization of the memory of the controller. So let's say if the memory utilization has crossed maybe 60 to 70%, then I know that I need to get another controller, pull it up and do a high level availability for it. And then there's a data channel utilization. The amount of data each open virtual switch can handle is limited because of its data restrictions. So if we know that data channel utilization percentage, maybe if it goes above 80%, it will automatically spin up another virtual switch and connect it to the network. And we have real-time statistics of the network or the data flowing through it. So if we say anytime the ICMP traffic is going up, so we know that there is something wrong with the network or someone is trying to attack it, and we can take the necessary action. and at the bottom we have all the logs. So logs can be like this: if a user has connected to the network, if the user has failed to connect to the network. So the administrator can take a look at this graph and say, okay, someone has failed to connect, now what action I need to take on it. So I can do, I can see this from the dashboard and I can take necessary action. So I have the logs from the control, so what we are trying to do, and I have specific logs regarding the user level. So one is the network level and the other one is the user level stats. So another intent is where user wants to design their own network. So right now these are all the companies which are using the Teneno service. So this, let's say each company has its own internal subdomains like management, technology, sales. So all the people in this company don't want them to talk to each other. You know, they want to divide it based on their maybe network groups or management groups or different groups. So we provide that facility using the design. So the user from the UI just specifies where the user should belong to, or which group the user should belong to. We will create tenants for them, and the tenants would appear like this. You know, the Teneno company right now, let's say, has two tenants. One of them, all of them in the same network, and another tenant, consultants who are working for them. Now everyone in the consultant are totally separate from everyone in the all group. Now the consultant cannot reach the all network. So this way we are doing a network level bifurcation of the network. So if I want to, in a traditional way, if I want to do this, I want to move the consultant back into my main network. If I have to go to each and every box, configure the policies and do it. Or right now all I do is I click a button in the UI, and in turn it is reflected as a policy and it is implemented as an OpenFlow rule in the network. This would actually take the user and put it back into the network. The user won't even know that there is something going on in the backend network, because everything is done and the policy is in an abstracted level. So this would allow the user to create internal networks by a click of a button. And the administrator can also see the network level view, or data, the layer 2 network. So he would see all the switches or the virtual switches which are connected, the points of presence, see how many hosts are connected to the network. So virtual switch might have a certain capacity, how many internal connections it can handle. So by looking at this, I can see, okay, if the number of connections are going up, I know that I need to take some action, bring a new whip switch onto it. And we can see this is running Open Virtual Switch and OpenFlow version. And we can also get the flow, internal port details of each and every Open Virtual Switch, like how many packets are being dropped, or how many collisions are happening in the network, and how much data is flowing through a particular port. So if I see this and see that there are a lot of dropped packets on a certain port, I can take any action on the port. And at the same time, I can use this data of received bytes and transmitted bytes to calculate the OSS and BSS for it. So this would actually enable the administrator to have a view of his whole entire network and manage his services. And the other application which we have in term is the PNT to SNT, that is the physical network topology to a simulated network topology. So the idea is like this: we have a physical network, right, connected, but I want to implement some policy onto the physical network. Now if there is something wrong with the physical network, if I implement the policy which is not good, then the physical network might collapse. If I am a big company, then I can buy a test environment and create all the policies and everything in the test environment, test it, and then go to live. But if I am a medium or small company, I don't want to invest on the test environment. What do? I take the risk and put it onto the production environment. So this is not ideal in any sense. So the solution what we came up is to take a snapshot of the physical network. So we take a snapshot of the physical network, put it into a virtual environment. So any complex network or minute network also, it takes a physical snapshot and puts it in a virtual environment. Now any policies or change management you want to do it onto a virtual environment first. See if the behavior is as per the requirement or as you wanted it to be. And once you are happy with the changes, by click of a button you can virtually push all the flows back into, or all the policies back into the physical network. So what we are trying to solve here is that in traditional way there is no, lot of cost is involved in creating such an environment. So if you want to create a test environment, you need physical equipment to do it. But here we're creating a simulated environment in virtual within a matter of seconds. Any complex network, it takes seconds to create a snapshot of it. So once the snapshot is created, users can create policies on top of that soft switch, see if whatever the behavior is it as per the expectations. If they're happy with it, they can then push them back onto the physical network. Now, as we can see, we are running a physical switch over here, which is from the PKI. It is actually running in their lab. We are remote connected into the switches, and we have the virtual network here, which is created and which is running the open virtual switch. Now, all the switches on the PNT and all those on the SNT are mapped. So, any policies you implement on the SNT will be actually converted into policies into PNT. So, they are in turn mapped back. This is one of the application. Now what we are advantage is for the user is that they have reduced their capitals because they don't want to buy any new equipment, and operation is almost, it takes seconds to do it, and it doesn't need any technical skill to actually go into the switches, configure them again, same as a production environment. It's easy to do it. And another application which we provide for the users is called a flow rector. Flow rector is basically a traffic optimizer. So I want to have a traffic path between point A and point B, right? So there might be different paths available. So there might be different paths which are available between point A and point B. So let's say in this case we have two paths. One is from here to here and the other one is from 3 switches like this. In this case, the shortest path might not be always the best path. The users want to have a path which has less number of collisions, maybe less number of transmit errors, or anything which gives them best quality of data transfer. So the idea is here to calculate the different aggregate cost of different paths existing and present it to the user. So once the user sees the different paths listed up, the user can select a path and use that path for his traffic diversion. So once the path is deployed, the traffic will be rerouted through that direction. So the advantage with this is that at any point of time your traffic is optimized. So let's say a user wants his administrator to connect to app server. So he says at any point of time, my traffic between my PC or my laptop to the app server should be optimized. What this do, it calculates the best path, present it to the user and route the traffic in certain direction. This application also intelligently takes care of rerouting the path if there is a better path available. So in the backend it continuously checks for path statistics, it calculates the costs, and if a new path is available, it immediately switches this path back to the new path. So in this way the traffic engineering is always maintained and the users' SLAs are met with respect to traffic engineering. And with respect to the dashboard and analytics, there are a lot of things happening in the backend. Like for example, if any of the VPOP is misbehaving, or there are a lot of ports in there, if any port is misbehaving, then the application Evolve will automatically analyze that there is something wrong with the port and it would take necessary action. A simplest of action which it would take is restart the port maybe. If there are a lot of collisions happening, it would restart it, or else if it understands that the port itself is wrong, it would rewrite the traffic to a different port altogether. And we have AI applications built into the analytics part. So for example, if there is a lot of UDP traffic flowing say between a certain period of time, at 11 AM there is a lot of Skype traffic flowing, at 3 PM there is a lot of link traffic going on. So the application learns it over the period of time and it takes a decision based on this. So it optimizes the traffic at this particular time accordingly. So these are all the solutions which we provide to the customers, and Teneno is one of the company which made use of this to deploy their NAS solution. Thank you so much.